So friends, here we are, and everything looks good for starting this new live event, this new live coverage. But I'm just giving you a chance to confirm on the chat for those there that you are listening to me. Okay. So Dodza, thank you for giving me confirmation, and I think that we are really ready to go. Let me see. Okay, just sharing on a few places that we are live now. And here we are, I think. Okay. Okay, just fixing a few things around. I mean, just letting know to the people, to the interested people, that we are live. Okay, I think that I did what I could to inform people that we are live right now. I see that you are receiving everything just fine. So I really think that we are just going. So I really believe that we can officially start this live feed, and just reading for a few more things. Okay, I see that everybody's having a good experience with the live video and audio, so I think I can really go and really start this live feed. So welcome, ladies and gentlemen, good evening to all. Gianluca Masi speaking from Virtual Telescope Project, and here we are again. I must say, we've seen each other many times this month, and we are here because another great event is bringing the sky to you through the web, thanks to the Virtual Telescope in the framework of the Global Astronomy Month 2014. Now you are quite used to what Global Astronomy Month is. I have been saying this many times, many events since April started, but also because you know from many other sources what Global Astronomy Month is, mainly by the organization who took care to plan, schedule and organize, after all, the whole celebration. That is Astronomers Without Borders, and I'm very happy to also bring to you greetings from Mike Simmons, president and founder of Astronomers Without Borders, and I'm also pleased to be the national coordinator for Italy for Astronomers Without Borders. So tonight we are here because we wanted to spy a quite unusual body, quite unusual celestial object. We have been doing a lot of things this month. We started in such a big way with the online Messier Marathon. Then we tracked an asteroid, a near-Earth asteroid coming very close to us, actually brushing the Earth. And a few nights ago, 2 nights ago, we also explored the planet Mars at its very spectacular position. By the way, I was amazed to see Mars yesterday by naked eye, and it was fun to see its very, very red color compared to the blue one visible on Spica, the star you have apparently in the same part of the sky. So I strongly suggest you to go there and have a look if you didn't so far, because it is a wonderful sight even by naked eye. But now we are here because we have another interesting object to show you, and that is the asteroid number 4 Vesta. So it is for me such a big pleasure every time that asteroids are actually part of our online activities, because I have spent a significant part of my scientific life to study and understand what asteroids are, with a particular regard for those coming close, and we always hope not too close to our planet. Anyway, tonight we will explore this asteroid. I will tell you something about this asteroid and asteroids in general, and for this I would like also to let me find a nice image that I already used when we actually observed the near-Earth asteroid a few days ago. Let me find it. I have so many things here that here it is. I find this one very, very important, because asteroids are very intriguing objects, and they are very, very useful to astronomers when they want to actually understand and investigate what happened in the solar system at the very beginning. We know that the solar system is about 5 billions of years old, the Earth is 4.6 billions of years old, while the Sun is a bit I would say older. The Sun has basically 5 billion years, and the Sun was the very first to start living here, and as soon as it started shedding light around, a disk of material, a protoplanetary disk, how we call it, was all around, and in slowly some major bodies are created by very small pieces all around that planetary disk. And we know today that those bricks basically were what we call asteroids. So if you really want to study something still around and as similar as much as possible to the pristine material in the solar system, you have to look for asteroids or even comets. Maybe that comets are still a better choice for this, because they were even better preserved by any thermal evolution because of the sun, but asteroids are really, really important for this, and we have a lot of them because we have really discovered a huge number of asteroids. Even if asteroids are quite a young population, I would say it's an asteroid is a young friend for astronomers, because the first one was discovered in 1801. So asteroids have a story which is a bit longer than 2 centuries, and the first one was discovered by a great Italian astronomer, by the way, Giuseppe Piazzi, who found the first one being Ceres. Now Ceres is also known as a dwarf planet, and this is another interesting story. But all this happened, as I said, on 1801 century, 1801, so at the very beginning of the 19th century, and this is a very nice, interesting story to understand. If you want, you will find also very, I would say, very curious things and people doing this asteroid stuff if you just want to learn something about the story of asteroids, how they were discovered, and how we are learning a lot of things from them. Anyway, what is important is that while we started discovering asteroids a bit more than 200 years ago, we now know a lot of them. We know basically about 600,000 asteroids, and we know that a significant portion of them are actually coming quite close to the Earth, and some of them can really brush our planet, and the Virtual Telescope has been sharing live many of those close approaches, so that is a topic where we are really strong, I must say. But if you look at the whole asteroid population, there are a few things that you can easily see at first glance, and to me the most intriguing one is what I'm going to show you right now. This plot that I think that you are now seeing is a graphical answer to a very simple question. You can ask yourself, knowing that there are so many asteroids, 600,000, you can ask yourself this question: how many asteroids you have at a given distance from the Sun? If you take the distance between the Sun and the Earth as a unit, okay, putting it as 1, your unit for measuring distances in the solar system, the famous astronomical units, and it is equivalent to about 150 millions of kilometers, a bit less than this, but just to work with round numbers, you know. And if you use that astronomical unit, you see that a huge amount of asteroids is sitting basically between 1.92 astronomical units to basically 5. Even if a bit more than 5, you have something there, you see. And this is a nice way to show the so-called asteroid belt. If you understand that at 1.5, 1.6 you have Mars from the Sun, I mean, you can easily conclude that basically almost the whole population of asteroids is just in the middle of Mars and Jupiter, and that is the main asteroid belt. Of course, we know that the solar system is a bit more complex than this. We know now bodies also in the very deep frozen regions of the solar system, but I still want to limit this discussion to the main belt, the one you are seeing here, and the asteroids themselves are making the belt quite evident. But you can also see that there are some strange, how do you call it, some strange holes there, because the distribution is not uniform in the as I said, in the asteroid belt, because there are some gaps. You can see that there are some very sharp gaps in the middle of the huge numbers of asteroids, and they are called the Kirkwood gaps, to celebrate the name of the guy who first recognized this. And we know that those basically empty regions, those gaps as I call them, are have a very important explanation. As also Kepler explained us, there is a strong relationship between the semi-major axis of the orbit an object is following around the Sun, and the orbital period, okay, of the asteroid along the orbit. But to put this in a simple way, if you put an asteroid just where you have the gap, you will discover that that semi-major axis, that value, the distance, will put the asteroid in a very strange synchronization with the orbit and the motion of Jupiter. In other words, an asteroid there will have a period maximizing the effects, the perturbational gravitational effects by Jupiter, and at some point the asteroid will be removed from there. This is just one of the mechanisms, the dynamical mechanisms acting there, so this is also a very important field of research for modern astronomers and people doing also great mathematics with all those things there. But at least we know that Jupiter is able to stress, to create some perturbation to that population, you know. And this is why, for example, at least to some degree, that those gaps are why we have asteroids coming close to us, because the asteroids removed from those gaps are, of course, sent in a different place outside the main belt or in the inner solar system where we are, so they can really become near Earth asteroids. So that plot was quite important and quite spectacular to see and to understand. That said, we have also some important information about asteroids, because that some of them are made by iron, some of them are basically stony asteroids, and there are several variations on this, of course. And we know a lot of things also because we have able to collect meteorites, and from those bodies who actually impacted, we were able to study also the parent body and to understand much better the nature of asteroids. Basically, meteorites give us a wonderful chance to study really an original true sample of an asteroid. Okay, so this is also a very important source for us of knowledge. And we've been especially discovering asteroids over the last 20 years. Since we started a few surveys around the globe to look for those dangerous and potentially hazardous asteroids, and as a byproduct, of course, we discovered really tons of ordinary asteroids. I mean, main belt asteroids. So this is why the number of asteroids has exploded recently, because this is a byproduct of our surveys looking for near Earth asteroids. And I would like to show you also something about the asteroid we are going to observe tonight, that is asteroid Vesta. I want to show you something about Vesta, a picture that I find very interesting. This picture is basically showing Vesta compared to the moon, as you can see. I hope that this makes things quite clear. And Vesta, if you look at the dimension, is the third asteroid in dimension. Its diameter, its mean diameter, you see, it is not a perfect sphere. You will see this better later. And its mean diameter is about 500 kilometers. This is about an half if compared to the bigger asteroid, the biggest one, I mean, that is Ceres, the one discovered, as I said, by Piazzi at the very first of the asteroid story. Actually, it was the 1st of January, this is funny, the 1st of January of 1801, when Piazzi discovered Ceres. But we are going to observe Vesta. It is the 4th asteroid ever discovered. I told you about the diameter, more or less 500 kilometers, and it was discovered by Heinrich Olberts on 29th of March. This happened 6 years later than Ceres, that is 1807. And of course, it is named, for those with some curiosity in mythology, after a goddess, a Roman goddess in the Roman mythology. It was important because Vesta was a goddess of home and hearth. So this is also important for traditions, you know. And another important thing is that Vesta is it is the brightest asteroid you can see normally, because likely it is able to send back a lot of light from the sun. I must say, as an astrophysicist, it has an important albedo. Albedo is just a number saying you how many light from the sun is sent back, is reflected basically. And Vesta is very important, is prominent on this. It is by far the brightest asteroid you can see under normal conditions. When Vesta is peaking in brightness, I mean, it is barely visible by naked eye if you are lucky enough to live under a dark sky. And another important thing to say about Vesta is that it was also explored for more than 1 year, basically, by the NASA's Dawn spacecraft, and that spacecraft was there from July 2011 up for 1 year from them, from July 2011 to September, if I remember right, 2012. And this image, the one you are seeing, is just, I will say, so efficient to show, to give you an idea about the dimension of this asteroid against our natural satellite, the Moon itself. As I said, it was discovered by Olberts. Olberts was a great astronomer. He also discovered Pallas, the second asteroid in absolute to be discovered. But Vesta, as I said, is a huge rocky asteroid, and I would like to show you also an important image we have for this asteroid. Let me load it again. I want to share this right away if I can. This image of Vesta you are seeing now is a postcard we received by the Dawn spacecraft, and you can see many details on the very ancient surface of the asteroid itself. And as I said, Dawn was there for basically 1 year, from the summer of 2011 for a bit more than 12 months. And this asteroid was is actually one of the very few we observed from space thanks to spacecrafts. And I have here a nice nice image showing all the asteroid we have been observing from space. Here it is for you. So Vesta, of course, is by far the most important, the largest asteroid of this small group. And if you just count, you see that we arrived to 8. The first one was Gaspra. This happened about 30 years ago. I still remember when the Galileo spacecraft, while on its journey to Jupiter, for obvious reasons, it had to cross the main belt, and scientists decided to use that opportunity to come close to an asteroid, and Gaspra was the first one. And then we also observed Ida, and Ida, you can see also it on this image, has a very small satellite dactyl, and this is a very important question on it is a very important discovery, because now we know many double asteroids and they are a very hot topic in science. And if we want to include to this image also comets observed by spacecrafts, I want to show you this one. And as you can see, you have less than 20 objects if you consider asteroids and comets. And you can see that the comets, at least the ones we observed, are basically smaller than the asteroids we have seen, and this is a very, very nice image to me. So here we are, and it is important to understand that in the past asteroids basically built the planets, and they also modeled the surface of the planets we see around these days. Also the moon, if you look at the moon, of course, even with a very little telescope, what you will see on the moon, craters, are the leftover of incredible impacts in the case of big craters. But of course, the moon without an atmosphere was even more easily reached by those projectiles, and studying the moon is an excellent way for us to understand what happened in the very ancient times, because planet Earth has no leftovers of those very ancient impacts, because the Earth, because of the natural elements, is continually reshaping itself, while the moon, with basically no water, no atmosphere, at least any evident mechanism cancelling things there, is still a wonderful museum for us to understand what happened and to understand better what is the real risk of collision these very same days we are living. But it is time for us to go and have a look at Vesta. I just want to remind you, by the way, that as I actually remembered earlier, that this event is part of a global. This is the logo of Global Astronomy Month, the remote observing programs, and of course this one is clearly a remote observing program, because we are using a remote telescope, and thanks to it we are bringing the wonders of cosmos directly to you. This is just fantastic, and I find very really great every time we end one of these online events. I really like to go and check from where the viewers were, and you see that you have sometimes at least 100 different countries, and this was particularly true, for example, for Mars a couple of nights ago, when we had more than 20,000 of viewers from basically 150 different countries. It was a global, I would say, international event in any sense. And all this is happening thanks to the Virtual Telescope project. I'm very proud to acknowledge how important this project is these days, because since it started a bit less than 8 years ago, Virtual Telescope is now the absolute leading facility in the world, broadcasting the universe live with a few millions of viewers each year. And for us, this is an important result, actually feeding our dream to continue this work, also with improved quality and improved service. And we are going to use one of our robotic telescopes, and here are the two very advanced telescopes we have available, and they are two fully robotic telescopes. The one you see on the left is 14 inches, and it is incredibly well fine-tuned for high precision photometry, for measuring the lights of stars and also for studying planets of other stars. He did a few discoveries here. It has a very big curriculum, I must say. While on the right you see our largest telescope, that is a very advanced optical device with a 17 inches diameter, and it is very powerful. In case it can see very faint objects, and of course it provides amazing images of the most distant objects in the universe. And we are going to use that telescope. This one I wanted to show you just a bit better for you to understand better what is going to show you the images we are ready to collect. Okay. Okay, it is time for me to go and view the telescope. Let me take care to show you the telescope console live, of course. I want, as usual, to make your experience as much real as possible. I think that we are ready. Okay, I think so. So just adjusting the output to be sure that you are seeing correctly everything. I think we are there. Okay. Yes, I think that we are finally showing the sky. Before starting, I want to show you this image. It was astronomy picture of the day. It was taken these nights because Virgo is hosting planet Mars as well, and asteroid Vesta is in the same portion of the sky where Ceres is. So here we have such a traffic of interesting objects, with Mars, Spica, showing such a wonderful contrast in their color. And then you can see also Ceres and Vesta there. Well, I find this is a wonderful sight. At least this is what I think. And then I want to go back and show you the telescope. Here we are, friends. So let's ask the telescope to point Vesta, but first, if you don't mind, as a bonus, I would like to show you Ceres. So let's ask the telescope to go there, and I'm just doing it. This is the telescope going there, and the red circles, as you know now, after a few events, is showing where it is in the sky, your destination, while the yellow is the telescope position in the sky. And when the yellow and the red are one above the other, you just are arrived. So we are there, and of course, while you are basically thousands of kilometers far from the virtual telescope, I really want to show you the asteroid of OK through our camera. So I'm just trying to make the camera ready for you. Here it is. Let me show you again. The bright object you see now is Ceres. We have it now in the center of the field of view, and it looks like a star, but it is not a star. It is really fascinating to understand that, of course, this is an asteroid after all. So we are really having a sight of the asteroid, and I find also quite curious that an asteroid is named after me, because someone in the astronomical community decided that I was worth such an acknowledgement of my scientific accomplishments, and of course I hope that the asteroid is happy. The funny thing here is that if you take an image now, as we did of Ceres, of course, and if you take an image of the same asteroid in 10 minutes, you should be able to note a slight motion, because during those 10 minutes the asteroid, of course, moved around the sun, and for this reason, of course, the asteroid will show its motion. And this is how Piazzi recognized that this one was not a star, even if it is a star looking through the telescope. But the motion, the very evident motion, after a few tenths of minutes, makes clear that it is not a star. Here we are. At this point, I would like to say goodbye to Ceres, and I see that Ron, I see a few friends on the chat. By the way, I want to thank all those on the chat right now, and in particular, I want to thank Dozza, Catherine, Ron, Serena, Susie, Zoran, Gary, Tatiana, Matteo, DJ. I have an handful of names there, and of course I thank you. And also there are other names that I don't know personally, and of course I thank all of you. I'm sorry, but for it was my mistake to just to shoot down the audio. It was my mistake while I was playing around for adjusting things here. And Ron asked for specifications. The telescope we are using has a diameter of 17 inches, so it's a very powerful telescope. Is an advanced optics, corrected Dal-Kirkham instrument, so really cutting edge optics. And the camera we are using is a 6 megapixel high quantum efficiency cooled CCD camera, and together this combination is able to push our sight to an observed object fainter than magnitude 23, and it is of course very important for doing science on very faint targets. But this one is Ceres, and we are going to look the true star of the evening, and that is of course Vesta. But before leaving, I just want to show you again here Ceres, and I just adjusted the image to show a star in the same field of view on the right. As you can see, it is impossible by just a very quick sight to distinguish the asteroid from a star, and the name asteroid was proposed by the great William Herschel, and the name is just, the etymology is just resembling from the Greek, saying that as a star, asteroids means as a star, referring to the aspect. If you look through a telescope an asteroid, disregarding the motion, the mere optical aspect is as a star. But I will leave Ceres. I will leave everything the same, the telescope, the exposure time and so on, because I want you understanding how bright Vesta is once compared to Ceres. So let's say goodbye to Ceres. I'm going to say goodbye to Ceres, of course, and I'm really ready to image the asteroid who made possible for us to be here for Global Astronomy Month, organized by Astronomers Without Borders, and having the virtual telescope playing an important role for remote online observing programs. So closing the window and back again. So we are here again. Let me fix, sorry, there is a thing I would like to fix immediately, otherwise I will do once again closing the audio at this point. Okay, I fixed it, so my friends, by now you will never lose the audio. Sorry for this, but tonight I have to handle a few things. I also can tell you this: the other telescope is doing some very important follow-up of a cataclysmic variable star. I decided to track after my Japanese colleagues notified me of something special happening there. So this is also why I am tonight a bit more busy than usual, because I am running the other telescope in the background. Anyway, the telescope is on Vesta, and I'm going to take another image, and of course I want to leave the same technical parameters, because I want you to easily spot the difference in brightness of the asteroid Vesta. So go and see this yourself. So going to start with 10-second exposure. And the telescope is just downloading, and you will see, I think, a very bright object, much brighter than Ceres. It clearly is much brighter. I will adjust the image for you. It is clearly brightest, and this is, friends, Vesta. We finally are ideally on Vesta. I also want to show you a few more things about it, but first of all, I really want that everybody is able to see it. This is Vesta, the asteroid we described, very bright. It is easily showing those the diffraction patterns. That cross of light is actually not a physical characteristic of the object, but it is just a diffraction effect, a normal one due to the telescope, just for those not used to astronomical stuff. And this is, of course, is a very, very bright object. I still want to show you this at the original scale, just enlarging this a bit. I must say that the thing is fantastic, because even with such a very powerful telescope, you see the stars are just pinpoint dot of lights. And I'm very amazed to see this, and I can anticipate something to you. Next summer, in July, Ceres and Vesta will be so close, apparently close in the sky, that we will show them together in the same field of view. A single shot will show them very close, and this will be done in July. So stay tuned, save the date, and in a few months we will observe Ceres and Vesta again, but in the very same field of view. This is to me just great, and I want to show you another thing. If you don't mind, I'm just going to ask just to give you the real time data. I'm going to ask to the Minor Planet Center. I want to ask what is the distances, what are the distances right now from us for both Ceres and Vesta. So let me translate this in kilometers. It's funny to do some maths real time. 1.64. Right now, Ceres is 245 millions of kilometers from us. So it is, as I said, almost, let's use round numbers, it is about 250 millions of kilometers from us, 250 million kilometers, while Vesta is 1.23. Vesta is significantly closer, and it is at 184 millions of kilometers from us. I'm really amazed to see how bright Vesta is compared to Ceres. Let me see if I can show you at a glance Ceres versus Vesta with very similar image parameters, so that you can really see at a glance what I'm saying here. I find this sort of comparisons very good. I'm just adjusting the images for you to spot this easily. Okay, I'm going to share you once again the live images so that you can recognize these right away. And look here, this is very interesting on the left, as clearly also visible from the image itself. You have Vesta, and on the right you have Ceres. Same imaging parameters, same thresholds chosen for showing the images, and the difference is huge. Vesta is much brighter than Ceres, despite it is smaller. Yes, it is a bit closer, but basically the main reason for this is that Vesta is reflecting better the light from the sun to us, and it is showing brighter, you see. I find such an image just great. Yes, DJ, you're right. Now Vesta is peaking in brightness. It is in principle visible by naked eye if you live under a dark sky, while Ceres is not that bright. If you look carefully, you see that right now Vesta is, as Marco told us, more or less 5.7. That is the best estimate I have. Sorry, it is okay, just adjusting. Okay, 5.7 Vesta. A normal eye in a dark sky is able to reach magnitude 6. So this is within the human eye capabilities, at least under good skies with a good eye. While Ceres is 1 magnitude fainter, it is shining at magnitude 7, and actually a difference in 1 magnitude means that the brighter object, which is it is a curious aspect, maybe a smaller number when you are handling magnitudes, a smaller number means a brighter object, okay? A magnitude 1 star is much brighter than a magnitude 4 star, and a difference of 1 magnitude is a factor of basically 2.5 in brightness. It just means that Vesta now is 2.5 times brighter than Ceres, and translating this in magnitude, as I said, you get that appunto the difference is just 1. Going to show you again this is for me truly funny, and let me see if I can take now another image of the asteroid. This is the old one. I want to take another one and see if we can actually spot the motion. I must say that the main belt asteroids are not so fast showing their motion, and sometimes it takes many minutes for this. You are used to near-Earth asteroids through the virtual telescope. They are moving in a crazy fast way, but with main belters this is not the case. So let me see if with just another image we can start spotting the motion of Vesta. Closing the image, and by the way, let me check the apparent motion of this guy. It is moving well, maybe that after a few minutes we can see this. So let me take another image. I love doing these things live. We are going, at least we are trying to go, to show the apparent motion of Vesta. Let's take another picture, actually using the very same imaging parameters. We are going and doing this. Thank you, DJ, for reporting us that you spotted Vesta with your binoculars. I love actually when people share here their very own experience. So let me see if by comparing the images I can recognize the motion of this object. It is quite simple. I will just, or maybe that we are lucky. Let me see if I can do. I can still say that we are lucky or not. Look, it is very easy to spot this. Just look at the vertical light baffle, and you will see that the asteroid moved, because if you look at the vertical ray coming out from Vesta, on the left you see that there is a little star a bit on the left, while on the other image that star is just on the ray. Just an amazing check, I mean. But another thing I can do is try to sum those images and see if this will show us the motion. I see, it's fun. This is nice. I'm going to impress you maybe. Look here. This is a truly fantastic demonstration. Let me show this full screen. Look here. I still want to show you this one. The natural scale is much better. Look what I did here. I just loaded the images, the two different images, and we had, and I registered the images against the stars. Then I just summed the images, okay? So the stars are sitting one above the other, they are aligned, while the asteroids moved, and you can see this very easily because the cross of the asteroids are now doubled. This is truly fantastic. I really like what we have been able to see here. This is, I must say, such a truly wonderful experience done live, just showing the motion of this asteroid. I think that you really agree that this is such a great test. Just to make things a bit clearer, here it is. And in a few minutes I will be, of course, taking another image so that we can still make this visible much better. I really like this, I would say, result we are showing. And if you don't mind, I would like to go and take another image of Ceres 2. Let me check also what the other telescope is doing. It is doing fine, I see. Okay. So let's move the telescope again to Ceres. So going back to Ceres. And then I will take another image of Ceres, taking it right away. So that we will check also for motion for Ceres. The image is coming. I'm always amazed after 8 years to see what a virtual telescope can do in real time for those loving the stars all around the globe, especially now during Global Astronomy Month. Okay, friends, I want to image again. I want to load again. I'm just closing images from Vesta. Going to open images of Ceres, and I'm confident we will see the motion pretty well. Look how really fainter Ceres is. Again, I am summing the images. I am just carefully superimposing the images against the stars, and the asteroid should show movement. Look this, friends, this is just fantastic, I think. This is just a joy for me to see together. Look, this is not a double sight because of wine. This is just Ceres moving. After 10 minutes or so, I can check this if you want, but what is important here is that the asteroid is just showing with its motion clearly. I also welcome my good friend Zoran, who really is doing a great job in his country, and we have been working also together, and I really hope to continue collaborating with Zoran, and this is what I find a truly amazing sight. Let me see if I can do something to make this vision perhaps even more. Let me see. Finally the best. So let me show this double Ceres full screen so that Marco can as usually do a great job just saving the image himself. This one is of course a double image, but just because it is the same asteroid, but meanwhile the asteroid moved, friends. I must say, this is just fantastic, I think. Let me see if I can find something, another important. Okay. A question about the time, as I say, the time needed to dawn to reach Ceres from Vesta. Well, it takes a few years. Okay, let me close this window. I cannot do many things together. Well, this is a question from Hem Reed, who asked, anybody know when our probe reaches Ceres? It will be in 1 year by now. Next spring, at least the northern spring, one year basically by now, dawn should be on around Ceres. So I want to go back again and going to image again our Vesta. And the telescope is now back and forth from Ceres and Vesta. It takes 1 year, well, actually more, because as we said, it took more than Ceres. The trip to Ceres started when, of course, Dawn left our asteroid, you know. So it will take from September 2012 to March 2015. So it will be more than 2 years and a half for Dawn to move from from Vesta to Ceres. More than 2 years and a half, while it takes a few seconds for our terrestrial telescopes. So let's take another image of Vesta. I'm going to share again with you the telescope site. I love sharing the telescope console as if you were there. Take the image again. 10 seconds. Look also, the camera is minus 25 degrees above zero. The colder the better for our very sensitive silicon-based devices for imaging. Okay, here it is the image. It was just on the bottom. Okay, this is the raw image, and let me see if I can do the same experiment. Let's say goodbye to Ceres, and let's open again the 3 images at this point for Vesta, if I remember right. Okay, I took 2 back to back, just 3 of them. Okay, let me adjust the contrast just to have a more natural sight. Go back to full okay, let's do this looking all the same, and let's make what we did earlier. I'm just summing 3 images of Vesta, and likely we should see a little train of Vesta clones. Let's see what will happen. Look, I find this one just fantastic. Look here, friends. 3 images showing 3 horizontal light pattern, diffraction patterns due to the spider of the telescope, of course. But what is important, we have 3 slightly moved images of Vesta. This is why you have an elongated Vesta, but above all 3 diffraction patterns of Vesta itself. Enjoy. I find this one truly amazing. The name of the asteroid is Ceres. It is Latin, and let me say that an Italian is the only one going to pronounce this perfect, because Latins were our fathers, so the exact pronunciation here is Ceres. Just the 5 letters Ceres, like the beer, to make it clear. But the asteroid we are observing now is Vesta, and as you can see, Vesta here is showing its triple pattern. If I just use the first and the last images, just reacting the one in the middle. Let me see. Oh, sorry, I'm just oh, sorry, this is good. Here you can see that the motion is clear a lot now. Let me see if I can just crop the image, because I have something in mind, at least I hope. Ceres, just for your own curiosity, was the goddess protecting Sicily in mythology. Sicily, the famous Italian island. And this asteroid, Ceres, was discovered by Piazzi from the Palermo Observatory in Sicily. So Piazzi decided to name it Ceres after the goddess protecting Sicily, to honor the fact that the discovery was made from that land. Please note that both the asteroids are moving around the Sun with a speed of a few kilometers per second. Okay, what you see here is the apparent motion, because the speed of the asteroid is combining somewhat with the speed of the Earth. Okay, this is why what we are seeing is the so-called angular apparent motion. And the full screen here is let me see if I can show this full screen for the joy of Marco taking care of saving everything for us. So I hope that this makes sense to you, showing the motion of the asteroid. I find this very, very spectacular, if I can say my thought. Fantastic, really fantastic. Okay. I would like to take a third image of Ceres 2. Ceres is basically a bonus here, because of course we were not expected to look at Ceres, but why not at the same time? Once you are there, after all, you can do this. Okay, the other telescope is doing its job just perfectly. So let's go again. Let's go and let's go back. Again, I want to show you this one with some detail. Double Vesta. It does not exist in nature, but you know why we have this shape now. Just summing two images taken apart in time, and this is what we can see. Hope that you like this. Great, Ron. I find this great. Oh, happy that one of our friends in chat is saying that his or her 1-year-old baby is now awake and pointing at the screen. And she is impressed. The baby is impressed also by the asteroid. Okay, great. I see that the sky never fails, making us saying wow. So go back to Ceres for third image of it. Okay, lots of fun, I must say, with these asteroids. I really like asteroids. otherwise. Great Dodza for your statement there. So taking 30-second exposure of Ceres. We are going to close with Ceres. Here it is, the new image of Ceres. We will do the same with Ceres, but before, let's ask the telescope to go again back to Vesta. Look how the telescope is able to point at the very center the object without any adjustment. This is one of the things I really love our system, and this is a professional, of course, grade mount making possible this. And let's take too early for let's wait John. Let's open the 3 Ceres images. It will be better to open the 3 Ceres beers, I know, but this is not publicity because Ceres is so well known that it really does not need our publicity. And after all, it is named after an asteroid, so it may be the astronomer preferred beer, I don't know. Anyway, stop joking and let's show how this triplet of images will average for us. Look, I think that you can see here very easily. Sorry, I'm just running too much. Look here, friends, this is just amazing to me. I love this image, needless to say. Triple Ceres. This is the Ceres dwarf planet, and you can see this easily thanks to the virtual telescope. Oh, Ron, I see that you are leaving. Thanks for coming, and I also want to thank you for joining the team going to provide live images of the total lunar eclipse, but we will be able to speak about this in the very next days. So thank you, and have a great day there, and thanks for coming while we are seeing this triple Ceres. But once again, let me do one thing, using the first and third image only, so that we will have a clear detached double image. This is just fantastic, I think. Look here, double Ceres, friends. I find this really amazing. You understood now what this image means. The asteroid is moving. We took images 20 minutes apart, basically. Then those images were registered against the fixed stars, so the stars are perfectly registered, and the asteroid was left to move, and this is the effect. The double object clearly visible. I want to show this again to you, as it is such a truly amazing shot. And we are soon going to take our last image of Vesta, and with that we will be closing this very successful, I must say, image. I just want to see. Okay, I was checking also the weather from time to time when I'm happy with our live. I don't check anymore the weather, but it is also important. Okay, nothing serious happening, so we are lucky and happy. So let's take the final image of Vesta. We are already on Vesta, just checking this. Let me go to show you again all those things. We are on Vesta, just pushing the take photo button. 10 seconds to go. While I love this technology making remote astronomy possible, I still prefer much more spending my time out there under the real stars. Here it is Vesta, very raw image showing of course pretty well the asteroid, just to give you a better vision. I want to quickly adjust contrast and brightness. Okay, just trying some preset. Here we are, so that our friend Marco can take a shot, the screenshot for this bright Vesta image. This is fantastic. I really like how we detected the motion of the object. Yes, MRID, the telescope, can be remotely used. You can learn how on our website. I strongly suggest you to subscribe the Virtual Telescope fan page on Facebook if you want. Otherwise, just subscribe the website thanks to the plugin you see on the bottom right, because we are going to offer many more events, but the most important one will be the total lunar eclipse we will have in a few days next week. So I strongly suggest you, if you like, to do this. So with this image of Vesta, we can now have a quartet, a Vesta quartet, like music. Let me close everything we have opened from Ceres. Goodbye Ceres, discovered by the Italian astronomer Piazzi, and going to show you the 4 images we have of Vesta. Actually we have 5, but 16 and 17 were really taken back to back. They are the very same, they show no differences, so this is why I'm just selecting the other ones. So let's do the very same. Averaging the images, and here we are, and we are done. Look friends, I love this one. Simple, but as always, simplicity sometimes have something great that words cannot explain. You can count 4 horizontal diffraction lines because they are 5 images. But if I go here, I'm going to try something I still not tried. I was just trying to see if I can I could show you, but they are too close anyway. Okay, nothing serious, I just wanted to show you, to be sure that we were having the best possible sight and evidence of this. I think so. Let me see if I can just resize this to match the full screen so that at least I can make possible for okay going to show this full screen to you if I can. Sorry, I did too much, because I really like the idea that our friend Marco can save this full screen for his wonderful collection of images. Marco has been really doing such a great job collecting images during our live feeds, and this one is just in the hope that will help Marco taking this final image of Ceres, of course, of Vesta. I'm sorry, but you know, this is not the real Vesta. They are 4 Vestas. At a glance, Vesta over time. I don't know how do you prefer to call it, but I find this one truly amazing. So we are really approaching the end of this amazing event. It has been such a pleasure for me to broadcast live Vesta Asteroids. I want to thank all of you for joining, and I want to remind you that we have 2 more events scheduled for Global Astronomy Month. And by the way, check also Astronomers Without Borders website, www.astronomerswithoutborders.org, and also check how you can support them, and also check finally if there is something for Global Astronomy Month happening around you. If not, why not go out there and do that yourself. That said, I was saying that we are 2 more events for Global Astronomy Month in the queue, and the big, most important of the month will be the lunar eclipse going to happen on the 15th of April, and for this we will be showing this thanks to a very precious, important cooperation. Ron, he was here, is part of the team, also the great Gary, great friend, really helping for this, and a handful of other friends like Joachim from Panama, and other friends around that are joining, and thanks to them we will be able to collect images from different places from where the eclipse is visible and broadcasting live, thanks to the virtual telescope huge audience and technology. So I really invite you to go back at least for April 15, because that is a truly amazing event. That said, I also want to thank Mike Simmons, president and founders of Astronomers Without Borders, and his collaborators for making once again such Global Astronomy Month celebration a great one. We are just still living it. We are just at the beginning. 1/3 of April is gone, so you have 66% or more of Global Astronomy Month in front of you. So I just wanted to thank Astronomers Without Borders for taking care of this and for partnering with us for the remote observing program. And I want to thank also the technological partners of the virtual telescope. They are Unitron Italia Instruments, Software Bisque, Badr Planetarium, Santa Barbara Instruments Group, and Planewave Instruments. And above all, I hope that you had fun. And once again, I'm pretty sure that the sky showed you that looking up is always rewarding, no matter what is your telescope, no matter if you have a telescope at all. Just look out there and stay in awe and reverence, and you will be amazed by what you will see. Should it be just a star, a bright star, a planet, whatever, the sky will never fail amazing you. Just go out there and make possible to the sky to knock at your own sensibility. That's all for me. Gianluca Masi, Virtual Telescope Project, wishes you a safe, great day, night, whatever you are on the globe, and stay tuned. And let's prepare for the next huge celestial show next time. Goodbye, friends. Thank you for coming. Take care.